This is the lecture on monitoring resource usage. We will look at monitoring virtual machines' resource usage of CPU, memory, disk, and network bandwidth. So best practices, would state to take a logical step-by-step approach to changes. So first of all, get a complete view of the performance of a virtual machine, not just from the operating system itself and not just from the vSphere environment, but a full picture. You want to know what the VM itself is doing, what the OS thinks it's doing, and also what the VMware environment thinks it's doing. Also, if it's a network issue, what is external to the vSphere environment? It may not actually be within vSphere itself. Take a benchmark. You know what the normal case is, so you can compare every day to whether or not there is an actual issue arising. Um, Identify the resource that the VM relies on the most, and again, this would depend on many things: the use of the VM, what it's doing on a daily basis. Um, Certain servers generally will not be heavily processor intensive unless they're processing video or doing some sort of calculations. But in general, basic servers are not huge consumers of CPU. Maybe RAM, but not so much the CPU. Whereas it's quite the opposite for desktops. So if you had a desktop that's being virtualized, maybe in a view environment, then CPU is definitely a major factor, as well as RAM. And so identify which particular resource the VM relies on, or which resources the VM would rely most on. That's going to be your Achilles heel, or your low point, and that's most likely going to be the resource that will end up constraining the virtual machine. Reallocate resources as needed as you identify any problems to make changes and reallocate them and adjust, and then take another benchmark once you've made the adjustments. And I think it goes without saying, but as the big orange thing on the slide says there, make casual changes to production. Or I'm sorry, don't make casual changes to production systems. Make sure it's methodical and thorough and thought through. And I would even say make gradual changes as you're going along, unless there is dire need for a drastic modification. Be logical and thorough about it, I guess is the point there. So what sort of monitoring tools are available to us? As I mentioned, you're going to want to look in at least three different general areas within the guest OS itself, within the operating system, Windows, or whatever the virtual machine is running. Then there's the VMware environment itself, the vSphere environment, and there's tools associated there as well. And then again, it might not be the VM or the environment. It might be external to vSphere. And so, within the guest itself, there's a perfmon performance monitor that the Windows has in Task Manager. But then perfmon DLL is actually a dynamic link library that is included with VMware Tools. And when you install VMware Tools, it makes some extra counters available to the Windows performance monitor. We'll look at that in just 1 minute here as well. IO Meter is another example of a freeware tool that you can install within the OS. And then, of course, there's the trusty old Task Manager, which sometimes helps us and sometimes doesn't. VMware tools are available as well. Again, so within the guest OS, you can get a kind of sense of what the operating system thinks is happening, but it's not necessarily VM aware or even knows that it's virtualized. So, it's kind of a one-sided picture, if you will. You need the other side of that, or another third of the picture, which would be using VMware tools. So what is the vSphere environment doing? There's a bunch of different tools there as well. You can use the vCenter performance charts that we have looked at and we will look at in some more detail here. There's a whole other suite of products that VMware has for vCenter and for View and for many other products. The vCenter Operations Manager. There's vFabric App Director. There's obviously the vSphere and ESXi system logs themselves that we can cull through to see if something's happening. And then there's some more advanced RASX top and ESX top that we can use to kind of look at some more details. And again, especially ESX top and RESX top and the vFabric App Director and vCops for that matter are not necessarily subject for this particular course, but definitely for some of the more advanced courses, you can get into some of the details on how to use those particular features. And then external to the environment, generally the network itself and maybe other servers that are out there. A couple of popular network monitoring utilities are Hyperic and Solar Winds, and they can monitor your network traffic and look at bandwidth and throughput and all kinds of fun stuff, as well as actually looking at other devices on your network. So surely you all have seen the task manager before, and then on the right there's a picture of the freeware utility IO meter. When you have VMware tools installed, these are just the general Windows performance monitor here, and looking at some of the additional counters that are made available. And so, like I said, that Perfmon DLL that is installed along with VMware tools provides these counters to the Windows Performance Monitor and allows you to look at not just looking at memory as a physical entity, but actually being virtually aware, being aware of the VM memory. So if you look at the object VM memory, you'll see all the different counters that we now have available to us. We can look at the active memory. We can look at the ballooned memory. So you wouldn't be able to even differentiate ballooned or not if you're just looking at what Windows thinks is physical memory. Now that we have access to the fact that this is virtual memory as the object, we have all sorts of different counters that we can look at. Same thing for the processor. Um, Rather than just looking at what the CPU speed is or the percentage of time or what's been going on there, you can actually look at CPU stolen time, effective speed, like a kind of a the effective VM speed in megahertz. So what the virtual translation would be there. You can actually look at the host processor. So within the virtual machine itself, we can tell what the host processor is doing. And that's a big indicator there as well. We'll see in a second if the virtual machine itself is constrained and pegged at 100%, but the host processor itself is sitting down there at like 10%. Well, then your constraint is within the OS itself, and you just need to give the operating system more processor or figure out what's causing the problem in the first place. But if it's just the particular applications that you're running on this particular guest need more processing power, and if your host is only at 10%, then your host isn't constrained. It's the virtual machine itself, and you need to give it more or fix it. So here's some of the performance charts that is built into vCenter Server. There's some overview charts and some advanced charts. I guess the thing I'll point out here is that if you go in and try to view these charts within the vSphere 5.1 client, the actual fat client that runs on Windows, there's a known bug, and the review charts do not display. It's broken, but it does work in the web client. I haven't seen this particular section of the 5.5 client, but I'm assuming it's been resolved. Surely there's a patch out there as well. So again, as I mentioned, to get the full picture, you're going to want to not just look in one world. You don't want to just look at the vCenter side, and you don't want to just look at the Windows side, but you want to look at both. So in this particular example, you'll see this is showing a virtual machine pegged at 100%. We have a single CPU pegged at 100%, but then if you look at we can look down at the chart there and see what the vCenter on the lower left there, you can see what vCenter was showing the CPU to do. So the chart doesn't actually match there. You can see we have some sort of inconsistency. Um, and so if we look at this another example here, again, the CPU is pegged and has been pegged for quite some time. And then if we look in vCenter, we can see that, yeah, sure enough, vCenter knows that the guest CPU has been pegged for quite some time now, average of, what does that say, 93% or something there. But then in the lower right, we look at all of the processors that are available on this particular host. So there's 4 processors. You can see the objects there, 0, 1, 2, and 3. And processors 1 and 2 have been pegged to 90 and 95%. But processors 0 and 3 are sitting there doing nothing. I mean, maybe 10%, right? So that's not a host issue. That's a VM issue. You've got 2 processors sitting there at 90% average, and 2 other processors sitting there at like 10%. And so, that's a VM constraint there. And you could just give that virtual machine some more processor, assuming you didn't have a contention somewhere else. Um, if we look at this particular example here, we can see, look at the CPU ready for these particular virtual machines. And in this case, we can identify that the virtual machines are constrained by CPU if high CPU use is seen in the guest OS. As you can see on the left there, you've got four different virtual machines that are all pegged at 100%. And then if we look in the vCenter, and we notice that there's high values for the virtual machines on the vCenter side as well. We can see that they're high there as well. So then this is indicative of the fact that the VMs are actually CPU constrained here. Is a You can use the charts to tell if it's memory constrained, if a virtual machine is memory constrained. And one thing you may think, oh, okay, well, if I'm ballooning or if I'm doing transparent paging, then maybe we're having an issue with memory. Maybe I need to get some more memory. Not actually true. Ballooning and transparent page sharing, you know, they're decent features, and they work well, and they don't necessarily degrade performance as long as the memory is still available. And so, in this particular case, you can see that the memory is high, but there's still memory available. Um, so as long as the virtual machines themselves still have enough memory to continue operating, and they themselves are not swapping, and the ESXi host is not swapping, then everything is running fairly normal and kind of according to plan. Now, on the other hand, if ballooning activity was high and the guest operating system was swapping to its local page file, then that virtual machine is definitely constrained for memory. How do you tell if the host is constrained? Again, if you notice swapping on the VM kernel, not on the guest OS, but if the VM kernel itself is doing a lot of page swapping, then the host is overcommitted and constrained, and you need to add more physical memory. That's the only thing you can do at that point, or move some of your virtual machines to another location, or reduce the amount of RAM that your virtual machines are using. In any event, there's no more memory available, and there's no way to virtually create it. You need to either reduce your load or add more. This is just an example of some stacked graphs. Uh, looking at in this particular case, active memory. Active memory is the amount of actual physical memory that's being used by a virtual machine or a host. So this does not account for ballooning or for TPS or any of the other methods that VMware uses to try to make memory available. This is the amount of memory that is actively being used, actual physical memory that's being used. And if you see that your active memory is high, then you can assume you're getting to the point of contention and the point where you may be memory constrained, and again might need to add some more actual physical memory or reduce your load in the first place. So how about disk constraints? Well, disk-intensive applications can bring your environment down. Think about your virtual machines are accessing those disks, and if those disks aren't available for swapping or for whatever reason, you can have issues. And if those, if they're locally attached, you're going to get good speed. But if you are trying to run, too many virtual machines across, let's say, like 100 megabit pipe, then you're gonna have a storage path constraint there. You put a couple machines running iSCSI or NFS over a single 100 megabit Ethernet connection, then you're gonna come into constraint real fast. And there's again different ways that we can use performance charts to look at the read rate and the write rate, and also the latency of read and write. And so we can look at it by different objects, by the host and by the virtual machine as well. And so we can look host by data store and all the different storage types, host by storage adapter, host by storage path. So you can see where is the actual issue? Is the issue with the data store itself, leading to maybe a particular drive or a LUN? Is it the path to that? So is it the network going to that particular storage array, or is it storage adapter itself? I'm thinking that only be for fiber channel if it's for a storage adapter. And then the virtual machine, you can look at, is it the disk itself or is it the data store that it's going to? Again, just a bunch of things you kind of put together to give you a full picture. And not to get into too much detail here, but just to kind of look at what does disk latency mean and what can it allude to. we'll look at two different types of latencies: kernel command latency and device command latency. Kernel command latency is how much time, or the average time, that the SCSI commands spend in the VM kernel itself. So it's passed off from the VM. It's sitting in the VM kernel, maybe because it's waiting for the device to respond. It's waiting to hear back from the network. Nonetheless, it would be sitting within the kernel itself. And high numbers being greater than like 2 milliseconds or so, can represent an overworked array or an overworked host. And the way that you can differentiate between overworked array or overworked host is you would then go look at the physical device command latency. And this is the average time that it takes the physical device to complete a command. So kernel command latency is the time that the SCSI command stays in the VM kernel, and physical device command is how long the command stays in the physical device, or the physical device takes to complete a command. And so this would be going across the storage area network to the array. And because we're going across a network, the numbers are a little bit higher here, but high numbers would be like somewhere in the order of 15 milliseconds. And so that can represent a slower overworked array, or disks even within that array improperly allocated or constructed. And so, again, to differentiate whether that the host or the array is overworked, if you're having high latency in the VM kernel, so if your kernel command latency is high, and then you go and you look at your physical device command latency, and if physical device command latency is low, being less than 15 milliseconds, then you can assume that the latency or the issue is actually in the kernel command itself. So kernel command latency, with a having a high kernel command latency but lacking the physical device command latency, would point to the host being overworked. So you have high kernel command latency, and you think, okay, it's either the array or the host. Let me go check the physical device latency. And if the physical device latency is low, then you know there's nothing wrong with the array itself. Well, you don't know, but you can assume, I guess. You might want to do some more research. But, it's stuck in the kernel. Okay, well, why is it stuck in the kernel? Is it because it's something the kernel is doing, or is it because it's just not getting a response from the actual SAN? Let me go see if the SAN's all right. Oh, okay, well, the response time on the SAN is okay, so it's probably the kernel. Conversely, you look at the device command latency, and device command latency is high. Okay, well, duh, that's why it's stuck in the kernel, because it's sitting in the kernel waiting for the command to come back from the physical device, from the SAN. And then you know that the issue is actually, or you can assume at least, further testing would prove that the issue is within, or it's pointing to the array being, or the SAN having an issue. How about network constraints? That's another one, right? So there's different tools you can look at to test the network constraints. I don't want to say all the time, but a lot of times the network constraints, if there are bottlenecks or network constraint issues, it's going to be external to ESXi, just because a lot of the constructs are internal or virtual. You're usually going to see those issues in the physical world where there are actual constraints on the throughput itself. Now, the one thing that I would say within the virtual world that could be a constraint is the lack of VMware tools being installed, and the lack of using the proper driver. So again, remember, if you have VMware tools installed, you can use the VMX NICs, and those do have a higher performance versus like the E1000 or the E1000E. And so that's one thing you might want to check if you have a virtual machine that appears to be having some network bottlenecks itself, is you could check and see if VMware tools is installed, and if it is installed, are you using the VMX NICs drivers instead of like an E1000? Maybe your application calls for that you have to use an E1000, but if you can use the VM network drivers, then you should. They give you better performance. Aside from that, though, there could be configuration issues with the switches or distributed switches, but a lot of times it's going to be an external issue, and you might want to look at the bandwidth between the virtual machine and its peer system, and kind of look kind of external to the system. Again, this is where things like SolarWinds or Orion would come into play, and would help you actually look at the network and get some details about the network itself. You can look at drop packets and latency and bandwidth and all kinds of stuff like that. Again, getting the full picture. It's another example of some of the performance charts that you can look at. This is within the overview panel. It's an example of advanced performance charts. If you click on the chart options, it pops up this dialog box. And then within this dialog box, you'll see, you have the chart type across the top, line graph, stack graph, or stacked per VM, the objects themselves that you're calling out, and then the counter. So, CPU usage, the objects themselves right there. It's not very descriptive, but 0, 1, 2, we're looking at CPU. If you look over to the far left, you'll see that we're actually on CPU real time. So we're going to be looking at actual megahertz here, I guess, if we're talking real time. And you just check which CPUs you want to maybe look at individually, or you want to aggregate together. So you check them all, and then you can pick down a little bit further there. The next box is counters. You pick which counters for that particular object you would like to include. Then you can do roll-ups and different sorts of statistics and all kinds of fun stuff. You can run these advanced performance charts across clusters, data centers, data stores, hosts, resource pools, virtual machines themselves, vApps, and you can do some side-by-side to spot performance issues, especially if you're doing a stacked chart. You can do some side-by-side stuff to look at how performance is across different hosts, or across, from maybe a single host across different virtual machines. You can use it to monitor trends and even use it for some of the capacity planning stuff. This is a picture of that same chart in the web client, so it just looks slightly different. This one right here, the previous one was the fat client, and that's the web client. But the same features are available, it just is kind of laid out a little bit different. There's a lot of different options within the chart, and I don't want to harp on this too much, but there's just different granularities. The real-time interval, the slowest, the lowest one is 20 seconds. So you can't get any more granular than 20 seconds. The smallest sample time is 20 seconds, and that's what they call real time. Every 20 seconds, an interval is snapped, and that's your real time. The real time stats are actually kept on the ESXi host itself in a flat file, and then periodically that flat file is rolled up and stored in a 5-minute increments on the vCenter server itself. So those real-time snapshots are kept on the ESXi host themselves, and then anything other than that is kept within the vCenter server. So there's different types of charts, as I mentioned. There's line, there's stacked, and you can actually do stacked by virtual machine as well. And this is not a class on statistics. I think you guys can figure this out. But the stacked allows you to kind of do a side-by-side comparison and kind of look at different hosts, compare different hosts within a cluster, or compare different virtual machines within a particular host. The objects are actual things, actual components that you're measuring, CPUs, RAM, network interface cards, and again, you can do them individually, or you can select multiple to get an aggregate. Counters are the statistics of those objects. So if your object was a CPU, some example of statistics could be used time, ready time, percent usage. If your object was a network interface card, it would be network packets received, or memory could be memory swapped. There's different statistic types. Rate would be the value over the current interval. So an example would be CPU usage in megahertz. Megahertz, we're talking about the number of cycles per second. So that's over time. Anything over time is rate. Delta would be a change in interval from previous. So an example of a delta measurement would be CPU ready time. And then absolute would be the actual value, independent of the interval altogether. So active memory, or what is the amount of memory that is being used right now at this particular point in time, not how much memory was used over the last second or 3 seconds or whatever. And then we have the roll-ups. So the roll-ups kind of aggregate all those. Not aggregate, it's a bad analogy. It just adds it all up, sums it up, and rolls it up to a different value. And I think this slide is kind of confusing the way that it actually words this. The the past day interval is a collection of 5 minute intervals. So if you're looking at the past day will have sample times of 5 minutes, and the past hour interval or the past hour rate has intervals of 20 seconds. And so what they're trying to say here is the 15-20 second statistics roll up to a single value is what the 5 minute one is. So every 20 seconds of value is collected and stored on the host, and then 15 of those 20-minute sections are added up or summed up to create a single 5 minute sample, because 15 times 20 is 5 minutes, right? So those 15-20 second statistics are all added together, and that's your 5 minute sample. And then so for the past day, that's what your sample will be. Your minimum sample will be 5 minutes. So if you go to the past day interval, it'll have a value every 5 minutes. And so if you looked at the past hour, it would actually have every 20 seconds. The past week would show sample times of every 30 minutes. And the way that 30-minute interval is created is by rolling up 6 5-minute intervals. There's all sorts of different logging levels that you can set. You can turn logging off altogether. You can show only errors. You can show errors and warnings. You can get informational, verbose, or just absolutely craziness, trivia. um, and so I guess the point here is, you might want to have some logging, but not too much, because you're going to blow your logs out and cause more trouble there with just using up too much space, unless you just have tons of storage and you don't care. But the general idea is to set it kind of at an acceptable level, maybe warnings, maybe errors and warnings. Kind of depends, I guess, on your environment and your adversity to risk. But then, once you get VMware involved, or you're having a continuous issue, then maybe you want to bump up your logging a little bit to gather some more information. So it's kind of just a decision for you and your team to make, but just to let you know that those different levels do exist. All these wonderful charts we talked about can be saved off as all sorts of fun things. It can be a JPEG, a bitmap, a GIF, a PNG, even to an Excel workbook if you wish. All right, so that was a longer one there. It seemed like it was going to be a short one. We're just talking about resource usage, but it's kind of a heavy topic. So hopefully now you know how to monitor a virtual machine's resource usage, the CPU, the memory, the disk, and the bandwidth.